Right. So, arithmetic sequences. Arithmetic meaning arithmetic, right? When you think about the word arithmetic, what do you think of? Science? Adding, subtracting, right? Your basics, arithmetic. So an arithmetic sequence is when a sequence is found by adding a term, adding to each previous term. So 1, 2, 3, 4, 5, 6. Every time they're adding how much? 1, right? So we're going to talk a lot at first about the common difference. You just told me that the sequence was found on the last one by adding 1. So if I had 6, 8, 10, 12, 14, how is each position, every next term found? Adding 2, right? So the common difference of that would be 2. So let's look at these 4 first. 3, 5, 7, 9, 11. What would the next term be? 13. 15. 17. How did you get that? Add 2, which means that our common difference is positive 2. Which is 2. Let's look at the last one though. 3, 2, 1, 0, negative 1. What would the next term be? Negative 2. Negative 3. Negative 4. How do you get to each next term?
Negative -1.
Minus 1 or plus negative 1. So my common difference is negative 1. Okay? So why don't you guys find me the next few terms and the common difference of those center 2 problems. Okay. 7, 10, 13, 16, 19, 22, 25, 28. What's your common difference? 3. 10, 8, 6, 4, 2. What's your common difference? Negative 2. Okay, so far so good? All right. So now we talked a little bit at the very beginning of class about that position letter n, right? Or n minus 1 or n plus 1. So when you're looking at a sequence, there's more than just the term itself, 3, 5, 7, 9, 11. You're looking at the position of the term as well. 3 is the first term, 5 is the second term, 7 is the third term, so on and so forth. So if I look at this example down at the bottom here, 4, 6, 8, 10, 12, and the common difference is 2. So they've pulled this table together where n is the position of the term. Right, the first term is 4, so n equals 1. And then a of n, or f of n, or t of n, or whatever it is, kind of like with functions, is the term given the position value. So if I said a of, in this case, a of 4, what is my position number for that?
1.
Whoa, whoa, whoa. A of 4. What did I replace n with?
Oh, 4.
4, right? So in that case, that means that my position is the 4th position. So when I go to look at my table, I'm looking for the 4th term, which is what?
10.
10.
That's so big for it.
Okay. So far, so good? Okay. Flip the page. We're getting into what we call the recursive rule, and we're going to just basically describe what's happening as we go, because that's what the recursive rule is doing. It's describing what's happening in the sequence. So if I look at, let's do 2 and 4 together. 3, 6, 9, 12, 15. My common difference would become what?
3.
3. So my common difference is 3. So if I'm making a table, I'm going to start with my first term, which is what? 3. My second term is, my third term is 9. My fourth term is 12. My fifth term is 15. Right? So if I asked for a of 3, what is a of 3? 9. Very good. If I'm going to give a verbal description of this, I'm going to talk about where did I start and what am I doing every next term. So where does my sequence start? 3. So my first term, or I start with 3. And then for every term thereafter, what am I doing? Adding 3. Okay, let's look at number 4. 3, 2, 1, 0, negative 1. What's my common difference? Minus 1. Okay? Again, with my table, looking at my position, my first term is 3. My second term is 2. My third term is 1. My fourth term is 0. Okay? So if I asked you what is a of 5, what would you tell me? Negative 1. Very good. Okay, so my verbal description says I start with 3. And what am I doing every time? Subtracting 1. How else can I write that but with addition? Adding negative 1. Okay, you guys give me all of that information for A and 3, 1 and 3, and you're going to find me A of 2, and you're going to find me A of, let's get crazy, 7. Okay, number 1, what's your common difference? 2. You started with, and what did you do every? And what is A of 2?
4.
Very good. Okay, number 3, what was your common difference? Negative 2. You started with, and what was A of 7? Negative what? What's up, Chris?
Is it better to say adding negative 2 or subtracting 2?
Say adding negative 2, because when you go into your recursive rule, I guess, because you're not going to give me the verbal description anymore, but it kind of connects that back. So A of 7, this was 1, 2, 3, 4, 5, so 6 was 0, 7 was negative 2. Okay, so now, your recursive rule. Think about writing in cursive, right? Everything is connected. So your recursive rule requires you to have the previous term in order to move on to the next. You can't get the 100th term without having the 99th term to find it, right? So we're going to talk a lot about, so in this case they used A. If I said A of n minus 1, that is the previous term. So I'm going to start with a recursive rule. So if I had, let's use something other than A, right? Let's use F. F of 1 is, give me a number.
4.
4. Okay. F of 1 is 4. So F of n, any position, is F of n minus 1, the previous term, plus 3. Okay. So now, you guys just gave me the verbal descriptions of everything, but you really gave me the recursive rule without writing it. So we started with 4, and this is telling me I'm adding 3. Okay? So this is how this translates into your recursive rule. Now, all I know is that my first term is 4. Okay? So my first term is 4.
Do you want us to exercise?
No, just follow along here. So f of n, f of 1 is 4. If I'm trying to find my second term, what would n be? 2, right? N would be 2. So I'm trying to find my second term.
I do that. I didn't say it.
I'll just name it up.
Oh.
So what's 2 minus 1?
1.
What was f of 1? 4.
That is so big.
And what is 4 plus 3?
7.
7. What did you do from here to here?
No, you did.
Okay? So, how could I quickly find the next term without doing all of this work? Plus 3. What would it be? And then the next term? 13. Okay? So, going back to this is telling me, what does this first line tell me? It's on your paper, the very bottom. What does this tell me?
That A1 equals 5.
A of 1 equals 5. Be more specific. What is A of 1?
A of 1 is the right side, so it's plus 5.
No.
What
What is A of 1?
5.
It's the first term. Thank you, Abdullah. It is the first term. The next line tells you what you're adding or subtracting every time. What am I adding or subtracting every time? 4. Adding and subtracting 4 to what? So not to the first term, to the previous term. Okay? So for the second term, yes, you're adding to the first term, but what if I was trying to find the seventh term? What would I be adding to? The 6. So we're always talking about the previous term. All right. So flip your page. Given the recursive definition, which is the same as my recursive rule, write the first 5 terms of the sequence. So looking at the first one, what's my first term? 7. And what am I doing every time? Adding 4. So what would my next term be? And then, 23. Okay. Do number 3 for me. We can skip number 2. I want to be able to we get through to the explicit. Focus back. So my first 5 terms were what? -5.
-3.
Uh-huh.
0.
Uh-huh. Oh wait, it's not 0.
That's 1.
1. And 3. Very good. Okay. So now, at this point, our recursive rule, when I look at my recursive rule, what 2 important things does it give me? So think back to when we first started. What 2 important things does my recursive rule give me? Sam?
The rule and what A is.
Okay, so my first term, and then the common difference, the rule, like what's happening every time. So when you're looking at what we're going to do is we're going to identify the common difference and match the sequence to their recursive definition. So if I look at the first one, 2, 4, 6, 8, 10, what is my common difference? 2. You're adding 2 every time, right? So my important pieces are this first term of 2 and a difference of 2. So look through your options. Which one has a first term of 2 and a common difference of 2? D. See? First term is 2. You're adding 2 every time. All right. You guys do the next few. Okay. What's my second one? B,
C,
and D is 10. Okay, the next one,
C,
C, and D is,
all
alright, this next one, E, and my D is, and then the last one, and my common difference is, very good. Okay, so the recursive rule, first term and common difference are important. You need the previous term. It is tedious. You're not going to use the recursive rule a whole lot. Because if you're using the recursive rule to find like the 100th term, and you start at the first, what are you stuck doing over and over? Just adding 99 times, okay? You don't want to do that all the time. So we're going to talk about explicit formula. So right here, I've got 2, 5, 8, 11. My first term is 2. My second term is 5 because that recursive rule says the common difference is 3, right? Okay. So what your explicit rule says is that you're going to take the first term and you're going to add, so I'm going to write it a little bit differently than it's written in this box. You're going to add the common difference times n minus 1. Now, a quick discussion about the difference between this and this. Alright, what's different? A is gone. This is saying the previous term. Because anytime you have like f of n or a of n, this is talking about a term. That denotes that it's a term. But with this is just the position minus 1. Right? It's not the term itself, it's the position minus 1. So when I go back here and I look at, let's say, let's go all the way down here. 4, 8, 12, 16, 20. Right? Let's pull out the important information. What's my first term? 4. So if I'm writing my explicit formula, I would say that a of n, so any term, can be found by taking the first term, which is 4. Okay, leave it there. That's all we've pulled out so far. So, bless you. You filled in a little bit of the recursive, you filled in a little bit of the explicit. So, 4, 8, 12, 16, 20. Now what else can I pull out from this scenario? D equals 4. Okay, so D equals 4, which is enough information for my recursive rule, right? My first term is 4, and every term after is the previous term plus 4. So there's your recursive. Done. Check. Please. But if I'm going to use my recursive rule to find my 50th term, I've got to do this 49 times. Nobody wants to do all that. So, let's think about this. My first term is 4. My second term is 8. My third term is 12. My fourth is 16, so on and so forth. Right? And my common difference was 4. So if I'm going to fill in the rest of this, I'm going to add my common difference times n minus 1. Okay, it makes no sense right now. I get that. I get that. But I'm going to try and connect it all together for you. That's your explicit formula. It's a formula that's given. We're putting the pieces that we know in. So now, if I was looking at my table, could I graph this? Yeah. My first term is 4. My second term is 8. My third term is 12. so on and so forth. What does that start to look like?
A slope.
Okay, a slope, which is part of a trend, which makes a line. There's what I was headed for. Okay, it's linear, right? Does a line have an equation that you can write for it?
No.
Yes,
Oh,
mx plus b, right?
Oh yeah.
What would be the slope of this line?
1, 4.
Not 1, 4.
4 over 1.
4, right? My slope would be 4. What else is 4? The difference, right? So your common difference is the same as your slope. So I could write 4n because my slope times the position. But that's not the only part of the equation of a line, is it? What's the other part of mx plus b? The b. What is the b? The y-intercept. Well, I have the first, second, and third, but my y-intercept is which term? 0. Oh, okay. So could I find my 0 term given this information?
Yes.
What would it be? 0. So this would be 4n plus 0. Now, let's look back at this long rule down here. Can I simplify this at all?
Yeah.
How?
Distribute the 4.
Okay, so if I distribute the 4, 4n minus 4, bring down the other 4, and what does that give you? 4n plus 0, or just 4n.
Oh.
Okay, the explicit rule, simplified, is just slope-intercept form. Okay? So let's look at the next one. Okay, so if I wanted to find the 50th term, what would be 50? What is 50th term? When we're talking about sequences, what becomes 50?
200.
No, hold on. Your position is 50. So what's 50? N. So 4 times 50 is 200. So my 50th term is 200. Okay, let's do one more together. Alright, 5, 8, 11, 14, 17. Somebody give me some important information out of that. Chris. D equals 3. Very good. What other important information do I need out of that? A of 1 is 5. My first term is 5. My first term is 5. Okay. So, I'm going to finish my recursive rule first. My first term is 5. So what is that next line going to say?
Plus 5.
Oh,
Plus 3.
plus 3. Good.
Small brain, small brain.
No. Stop with the big brain, small brain. Okay. Your first term and every term after, you're adding 3. Okay. So now we have enough information to fill in this long formula. We have the first term, which is 5, and we're adding the common difference, which is 3 times n minus 1. But let's do it our easy way. My first term was 5. My second term was 8. My third term was 11. So what would my 0 term be?
0.
Stop.
2.
2. Okay. If my sequence is the first term is 5 and every term thereafter is adding 3, what's my slope? 3. So let's put it together. 3n
Plus 2.
Very good. 3n plus 2. So to find my 50th term, 3 times plus 2 is 152, and I can also graph this. I have 0, 2, 1, 5, 2, 8, 3, 11. Don't connect them because it's a sequence. It's not a connected line. There's not value in between. Just put the point. Okay, does that make sense? Yeah? Slope and y-intercept? Connecting it back to what you already know? Okay, that next page is your homework, and you have time in class about 5 minutes.